Cool. Okay, I think everything's all set up. Okay. And then we'll move this over just a little bit. All right. Did I forget anything? Good. No, I think we're good. All right. Hello, everybody. It is it's a little past 3:10. Apologies for that. I, James, and Annie are going to be teaching today's lecture. We're going to get into some really cool stuff, and you'll finally start getting out of the basics of Python. So like, no more of like, those like 61A like Python puzzles where it's like trying to do like find the maximum of two numbers. None of that boring stuff. We'll get into some fun stuff today. So you'll see an example of what we could do with Python just off of like the very, very basics of Numpy and some new library we're going to talk about today. So we have a little bit of announcements. Third homework is due today. No, that's the second homework. Sorry. Second homework is due today. Third homework is coming out today. Don't pretend that's not on the slide. So yes, second homework is due just now. Third homework will be released after lecture today, as well as the lecture slides and lecture recording for today as well. Just out of like show of hands, give me like a 5 for like good, it went well, 1 for went really bad, and then anything in between. Just like, let me see, because I'm curious for homework too. Wow, really? Okay, that's pretty good. Yeah, no, it's all good. It's all good. We're happy. We're happy that you most of you found it okay. If you struggled with it though, please don't feel bad about that. Come to office hours. My office hours on Friday. Annie is there with me, and we were really sad when nobody showed up the past 2 weeks. So we're like, we want people to come. I know it's a Friday and it kind of sucks. Apologies, but if you can, we'd love to see you. So yeah, office hours. Thanks to those who showed up. And get help if you need it. There's 5 days a week, and we also have a piazza, which the interns are actively on. So if you have questions, feel free to post them. If you haven't needed to yet, you probably will at some point. So make sure you don't hesitate to use it. So I want to get into a little bit of recap of last time on Monday. So I guess I have like 2 questions. We'll do kind of like breakout room style, but in person, because Zoom is not fun. So the first question is like, what are some differences between a NumPy array and a Python list? We talked about this on Monday. Just like some key differences, like how do they behave? What happens when you multiply them? Things like that. Discuss that. And then if you have some extra time, I would love it if you could think about why would you ever want to use a 2D array, a 2-dimensional array? And if you're really thinking about it, what about a 3D array, a 4D array? Why would you ever want to use more than just a single list line or like 1-dimensional array? What do they remind you of, and so on? So go ahead and think about this. Talk with your people around you at your table. We'll give you a couple minutes, and then we'll kind of circle around and just chat. So you have 5 minutes. Yeah. Cool. And should I put the 2 people on the Zoom in a breakout room? Should we do that? Let's see. We could chat here. Oh yeah, y'all could just chat here. Okay, yeah. If you want, you could speak, or just type in the chat. It's totally cool. Ooh, look at this. Cool. All right, I'll let them do that. Yeah. So I'll talk about my stuff. All good. Oh wow, you have. I mean, I'm gonna tell them where we got stuff. Oh, I'm like showing the chat. My bad, y'all. Do they remind you of? Man, me too. What do they remind you? What? Did I make a typo? No, we couldn't read it. Oh. Oh. Yeah. I'm not like savvy. I don't know how to make the things like disappear and make it look all cool.
To do literally anything. No, not anything. But like we're doing like yeah, pixels and colors. What do they remind you of? They remind me of matrices.
Yeah, there you go.
Anything matrix models.
Transformations.
Unless you have infinite matrices, in which case you need a whiteboard and a little bit of math.
Well, if you have an infinite matrix, how are you even gonna like do anything with that on a whiteboard? How do you multiply an infinite matrix?
I don't know. My professor did it last semester, and I was just like, no, sure, classic, bro.
What? What
You
class
have
is that?
n aspects of a matrix by n aspects of each aspect of a matrix. Classic, no classic.
I guess.
And we're performing an operator onto every aspect of this matrix. Classic. Totally.
That's
Absolutely.
terrifying.
Yeah, no, it was. I know you was good on this.
Yeah, right.
I want more matrices that are infinite. This is pretty good.
True. For regular ones, I think that's their time.
All right. Okay, let's reconvene. Hello. Where did it go?
Oh no.
That's tragic. While I'm trying to figure out this technology, does anybody want to answer the first question? The differences between like NumPy arrays and lists? Anybody? Yeah. Exactly. So like we call that the actual like term for that in like coding speak is called broadcasting, array broadcasting. So lists, like we said, when we multiply them, they kind of like just add on top, like not on top of each other, but side by side, if that makes sense. But NumPy built it in such a way that when you do an operation, it broadcasts, meaning it sends the operation to every element in that array. And it also works not just on a 1D array, but on 2D arrays, 3D arrays. So if you have like, you know, maybe, well, I guess before I get into how that explaining that, does anybody have any ideas what a 2D array would represent, could represent? Matrix. Any other ideas? An image, exactly. What is an image? It's just a bunch of pixels of different RGBA color values. So in fact, actually, you can think of it as a three-dimensional array, any image, because you have your X and Y for the first two indices. And then you have a third telling you, you know, like your red color value, your G color value, your B color value, or your A color value, like 4 different things there. So you can you can like use n-dimensional arrays for whatever you need. It's typically we get stuck in this box of just thinking of like matrix and then line and then like maybe a cube, but then after 4 it breaks down and you can't think of those dimensions like that anymore. But we can think of them as like parameters to change essentially. Let me reshare my screen. And I think we're still recording. Can the folks on Zoom still see my screen, like the slides? Yes. Okay, good. All right, so good discussion, and let's get into some new stuff. So I want to, before we get into any really fun stuff, I want to give a couple remarks on NumPy that we didn't get to cover on Monday. Those remarks being a really useful function from NumPy, or 2 of them. We call them arange and linspace. So numpy.arange, or if you import it as an alias, remember an alias is like the nickname. Import NumPy as NP, typically NP for short. np.arange, np.linspace. These functions allow you to make or like one-dimensional arrays, aka like fancy list of values, however many you want, between a start and a stop number. So that start can be 0 to 2pi, or start at 0, end at 2pi. That's what start is and stop is. So start 0, end 2pi, or stop 2pi, and then the number of steps. So for linspace, it works. You give it a starting number and a stop number. and then the number of steps you want to take in between. So maybe set that to 100. You'll have 100 evenly spaced, linearly evenly spaced data points in between 0 and 2 pi. Okay, so that's Linspace, and then A range works basically the same as range. We used that in the previous homeworks. If you remember, like the range of like 10 gives you a kind of like a list or an iterable of numbers between 0, 1, 2, 3, all the way to 10, or not including 10, so 9. NP.A range is basically the same thing, but instead of making like a list of numbers, it makes an array of numbers, which is just easier to work with. So you can think of NP.A range as the same thing as range, but with a little bit more flexibility. You can make it go every other number. So instead of like 0, 1, 2, 3, you can make it go 0, 2, 4, and so on. You can make it skip numbers. You can make it stop at whatever you want, start whenever you want. Just a little bit more flexible than a typical range as well. Yeah. No, that was a typo from previous year. Thank you for catching that. I'll make sure I fix that before I upload them. You don't necessarily need to do that. Cool. Any more questions? Cool. So you might be wondering, okay, why do I need to make like a bunch of numbers in between two values? Evenly spaced. That'll make sense in a little bit when Annie gets into her part of the lecture. But for now, I want to talk about data. So data science is a huge field. It's how you make a lot of money. No, but in a more noble sense, data allows us to explore the world and understand trends in the world without just like describing it, but actually giving it a quantitative meaning. You can actually describe trends with fitting functions and so on, and just like computing statistics and so on. So it's important that we understand how to work with data as like programmers. So let's talk about that. You might be wondering, how do you get data? Well, there's lots of ways to do it, but there's this really cool website called Kaggle. It hosts a lot of like competitions for like machine learning and data science. It's very fun. You can go on data sets. We were actually playing with this today, and we found a really fun data set to work with that I think you'll enjoy. The whiteboard might be indicative of what it is. But let's say you wanted a data set on Donald Trump's tweets. Hold on, we'll find it. Oh no, the Wi-Fi is not working. Yeah, my Wi-Fi I don't think is working properly. But if I did have Wi-Fi working, it would work. So I encourage you to Google Kaggle on your computer, Kaggle, like this. Go to that website. I don't know why my Wi-Fi isn't allowing me to work on the, I guess the Zoom's working, but I don't know why the website's not working. But if you go to that website and go to data sets, you can find whole bunches of data sets that go anything from COVID data to tweets of like famous celebrities, stock market prices. I don't know. They have like a whole bunch of images from Lord of the Rings, galaxy images, whatever you want. They have tons of data, and oftentimes there's cash prize competitions that you can enter in and analyze and try to find trends in. Really cool stuff. So that's a good place to find some data. And once you have your data, you can load it into a Jupyter Notebook and work with it. So how do you do that? We use another function from Numpy. There's many ways to import data, but Numpy has a nice one. It's a little finicky sometimes, and we'll learn more sophisticated ways to deal with data as we progress through the course. But I think the easiest package, or the easiest way to ease into it, is just through Numpy. So np.loadText is just a function that allows us to read in text files. You give it a few key arguments. We know how functions work now, so we know everything in the parentheses is a different argument to a function that change it in some way. So the first is always the name of the file. It could be like, I don't know, data.text, TXT, spelled just like this load text. We don't put the E there. It's just like a file extension. .txt files typically follow the ASCII format. It's just some format. It's not important to know exactly how it works. There's different ones like CSV, which stands for comma separated values. And there's other ways to arrange your data so that it like saves into a file. But .txt is a pretty common one. So you give it a file name with the extension. So file data file.txt, make sure it's in the same directory, or you route it to the right directory by putting paths before it. Then we have a delimiter. So the delimiter is a little confusing to get at first. All it is it's telling the computer when I'm reading through the data file, how do I know the number stops and I go on to the next one? So in this case, text files don't really have like a specific delimiter. It's just like a space or a tab. And the default we set to none. But for a comma separated value table .csv, they separate all the numbers with a comma. So if you open up a CSV file, you'll see commas after every number. And basically the code is like, okay, I'm reading. Oh, there's a comma. That's the end of that number. Move on to the next one. And I read, and then I end with the next comma, and so on. So there's different delimiters for different file types and so on. That's all it means. Skip rows, pretty self-explanatory. If I want to skip a row, I set that equal to 1. Skip 2 rows, set that to 2, etc. Use columns, use calls. That's one more important, like an important argument. And all that means, or all you need to do is give it like a list of column numbers that you want. And these are like column indices. So if I put a list with the number 0 in it, that means the very first column. That would be the North America, United States column. If I put in a list with just a 0 in it. If I put in a list with a 1, I get the dates. A list with a 2 in it, I get the whatever's after that, and so on. And I could put 0, 1, 2 in a list, and that would give me all 3 columns right there. So it's just a list of column indices that you want. And then lastly, we have unpack. Unpack is just an argument that changes, or it basically transposes the data into a shape, or into a into your NumPy array. So for example, we have this entire data set. How many rows we have? I don't know. Maybe let's call that 30 or 40 rows, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns or so. 11 columns and maybe 30 rows. If I load this in without unpacking it, it would give me an array where I think the indices would be like the first set of indices. Like if you index, like we have the 2D array, it's separated by a column or by a comma, and the before the comma is your like one axis, and then after the column the comma is the second axis. In this case, it would give you 30 rows in one, and then 11 in the other, and then unpacking, setting it equal to true, just swaps it. So it's just performing like a transpose, if you're familiar with linear algebra, or like rotating the dimensions. It's not super important. If it's not working as you expect, try setting it equal to true and then working with it. It might help. You'll explore this more in your homework. It's not super important to really understand how unpack works. Just know that it transposes this data set by like unpacking it into your. It's not super important. Oftentimes you could just ignore it, but it can be useful. Yeah. Yeah. So if you just don't even include the use calls, it defaults to just all of them. Same thing with unpack, it defaults to false. Delimiter defaults to none. Anything with an equal sign, it's what it defaults to. So if you just put the file name, it'll just load the entire data set into a NumPy array for you. And then if you want to rotate it into to change the indices and what they correspond to. So if like you wanted 0, 1 to correspond to like the second North America, or like, so in the 0th row, second item, that would be, you can set unpack equal to true to change it from being that to the 3, 1, 20, the first date in the second column. It's just like rotating your indices. It's not super important. Okay. That was a botched explanation. So let's just look at it. Let's look at an example. This is an example. Data is equal to np.load text, and then you give it the file name, sample data.txt, and let's say I skip the first row, and then I print the data. It'll give me a NumPy array with that data. Super simple, as I stated. So you might, once you have your data loaded in, you're going to want to maybe apply some conditions to it. So let's say I have a whole bunch of data I don't know, a whole bunch of data of stock values of Facebook. And I want to find when the stock value rose above a certain number, maybe $1,000 per stock or whatever. Then I can apply a really cool function called np.where. So I can apply some condition to my data and basically funnel out or sort out all the data that fits my condition. You can imagine the kind of the useful applications of this. So np.where, if you give it a condition, it'll give you some indices that you can feed back into your array or index with your array, and it'll give you a new array where you can with the values you want. So let's look at an example. We set a equal to np.a range of 10. So this is the same thing as range of 10. It's exactly the same, except it's just in a numpy array instead of like a list. Then we use numpy.where, and we set a less than 5. So it's asking, okay, where in this range, like where are the indices that a is less than 5? And it'll give you something that looks like this. It's a little weird why it looks like that, but it gives you an array of all the indices. So we get 0, 1, 2, 3, and 4. As we expect, those should be less than 5. Those are the indices. It's a little confusing because the list itself is the same as the indices, but it'll make more sense on the next slide. And it looks a little funny. You'll notice there's like a comma and it's like an extra parentheses. Why is it looking like that? Well, it's a tuple. It's not super important. So if you want to make it look really pretty, you just add a 0 index to get just the array item without the comma. There's other functionalities you can use this for to use things after the comma, but it's not important. In fact, you could literally just plug these indices straight in and it wouldn't matter. It like skips everything after the comma. So an example of this is the following. So let's take that same a range, just a range of numbers from 0 to 10, but then we multiply it by 10. And this broadcasts the number 10 to it. So it creates an array that looks like this: 0, 10, 20, 30, all the way to 90. Remember, we don't include 10. We only go up to 10, but we don't include it. Cool. So now we have this array, and I want to find the indices where a is less than 50. Same as before, but now we're actually like, it's a little different than just the indices themselves. So if I plug those indices back into A and index by them, it's like a list of them, it actually gives me the values in the array that I wanted. So 0, 10, 20, 30, and 40. That's what we use np.where for. So you can use np.where for anything. Maybe you want to plug it into like a 2D array that characterizes the pixel counts of a astronomical image. And you want to say, oh, I want to know where the flux or where the brightness, where it's the brightest in this image. It has to be above a certain brightness to look at the galaxy. And I want to set everything else in the image equal to 0 so I don't see it anymore. That's a typical use of this. There's many, many others. Any questions about np.where? Okay. If there's no more questions, then I'm going to give it over to Annie. I'm going to hide this thing so I can. Yeah, there you go. To start talking about a really cool package called Matplotlib.
All right. So, oh, nothing's coming up. Oh, there we go. So the way you start with Matplotlib, it's kind of like when we were going over NumPy. This one, it's just import matplotlib.pyplot as PLT to shorten it because you don't want to write all of that out. And yes, any type of research you need, especially if it's astrophysics, you will be using Matplotlib. I know I have. So the first most simple thing you could probably encounter would be just a regular straight line. In this case, you can either write it as, say, like a 2D array with one part being the x values and one part being the y values. So that would be like the plt.plot array. Or you can split it up and you have one array as the x values and one array as the y values. So the example we have here, let me just move my face out of the way. This one, you have 3 points. That's why it's np.a range 3. And we're graphing y equals 2x. And to show that, kind of like what we did in the top, it's plt.plot x, y. And then don't forget to use plt.show at the beginning, or not the beginning, at the end, after you've typed everything out, or else nothing will show up. And now, if we're trying to show something curved, you can write it out as like x squared, x cubed, whatever curve function you're dealing with. But the kind of odd thing about this one, does anyone know why it actually isn't curved in the picture? Yeah, exactly. Because the range is so small, it's just going to be showing those 3 points. So we don't have enough points to actually show a curved image. But in the next one, we have 100 points because we have np.linspace 0 to 3 and 100 points. So that's going to give you a nice curved image. And it's the same thing as before, plt.plot of x, y. Now, if you want to do multiple curves, in this case, we're doing just simple trig functions. The np.linspace, we're going from 0 to 2 pi. So that's why it says from 0 to 6 at the bottom. And with 100 points, because we want a nice curve. And all you have to do is you just type the first one, which is your sine curve, and the next one is the cosine curve. And both of these curves are going to show up on the same figure because the moment you start calling plt.plot, it creates something called a figure. And both of those are just going to go into one figure unless you decide to create another one. And if you want 4 curves, it's something similar. In this case, we used a loop. And in the figure, we have 4 different functions for the 4 different values of p, which would be like x to the 1, x squared, x cubed, and x to the 4th. And these all end up as different colors just by default. If you want to change the colors of the lines, that's something we'll go over later. And of course, for scatter plots, instead of doing plt.plot like the other ones, you just write plt.scatter, and that'll give you dots instead of lines. And if you want to have random values, then you do np.random.rand. And in this case, we wanted 20. So we put 20 there. And don't forget to definitely assign the same number for x and y, or else things will be very bad. And if you want different types of plots in one, similarly to before, you can just write them out separately and it'll show up on the same figure. So no worries about that. But in this case, we have one scatter plot that's a sine curve and another that's the regular plt.plot. And here are a whole bunch of different ways that you can customize your graphs. We have c equals red for the color of the line, and s equals 1 for the size, which is like the thickness. And alpha equals 0.8 refers to the opacity. So if you want to be more opaque, then you would choose a larger alpha value. And the marker refers to, if you go back here, I'll go back to the other slide. If you look at the scatter plot, marker would make those dots into like asterisks, or you can change it to other symbols and things like that. And we always want to make sure our plots have titles, and that would, it's not here, but that's plt.title, and then you just put your title in quotes. And for labeling your x-axis, that's plt.xlabel of x, and y-axis would be plt.ylabel. Any questions? All right, then time for the demo.
I'll do like my bit, then I'll pass it back over. Okay, yeah, so just really quickly, just to reiterate, Matplotlib is a package we use to make plots. I just want to hammer home kind of like the title of this past slide. Astronomers make the best plots. We will show you how to make good plots. I don't want to see garbage plots coming out of this class ever. Sorry if I sound stern, but it's a condition I have to keep you to, or like an expectation I have to hold. So we will show you how to do that. We have resources for you to make really good plots. In fact, a resource that just got uploaded today is the Ultimate Plotting Guide. You can walk through that entire guide and it will show you how to do all the plotting related things that you will possibly need for this homework that's coming up, as well as anything in the future. It's kind of all the basics that you could possibly need. It's on the B courses. You can go to resources and you'll see it there. But yeah, let's go ahead and get into some demo. I need to plug in my computer. So let me go ahead and open up a Jupyter Notebook for all of y'all. Just like we'll go to a new terminal. Can everybody see that terminal? It's a little small. Make it bigger. Okay, so I'm on my desktop. I'm gonna go to the Python DeCal folder that I have this in. And I'm gonna go ahead and do Jupyter Notebook to make a Jupyter Notebook, or to like make the environment that'll open it up. And now we're here. Hopefully all of you are very familiar with that by now, after doing a couple homework assignments. And we have a nice little demo, plotting demo. This is also available on the B courses if you want to download it, follow along. It looks like this, but I will start from scratch, so don't worry. We will make a new one, just like this. And let's go ahead and get started. So there are some key things to think about when you're coding with these packages, and we will start with loading in some data. So where it is, there it is. So we can start. We always, whenever we do any coding, we always need to import our packages. We call this the preamble. So we'll import NumPy as NP. Everybody should be able to see that. And I hope we're still recording, but whatever. And once we import that package, we have all of NumPy's functionality available by just using that np dot syntax. So once we have that np dot syntax, we can load in some data. So I happen to already have this data put in the directory that I'm working in. It's in this directory. So when you download the data from the B courses, make sure it's in the same folder or directory as the notebook you're working with. It's like a very common problem. If it says can't load file, it's probably because it's in a different folder. So just make sure that they're in the same folder. Once we have that, we'll use that np.load text that we discussed on the slide at the very beginning, just like this. And the name of the file that we're going to be working with today is just called dogecoin.txt. And I'm going to add a comment by using this hashtag. That's how you comment. Just the computer or Python interpreter will just skip over it. So that's how you can make your code like more legible if you want to explain what's happening in a code. And just for all of you to see, this data is going to be values of Dogecoin in US dollars over time. Okay, so now that we have that, I'm just so you know like why it's just going down every time. I'm pressing Shift Enter, which is a shortcut for just running the cell. So whenever you see it move down a cell, no, I'm Shift Entering. Cool. So now that we have this data, we can look at the shape of this data, and this will make more sense when I talk like with what I said about Unpacked in just a second. So now if I look at the shape of the data, we just see it's 1,500 values in like an array. The comma is there just because of the way the function works. But if I set unpack equal to true and did it again, oh, it doesn't change it because I only have one dimension of data. It's like a one column data file. I could show you exactly what it looks like in a second, but there's only one column, so it's not doing anything different. But if there was multiple columns and multiple rows, it would swap the indices. So everything like this 1,500 before the comma would switch to after the comma. That's all. It just switches the shape, and the way you access it would be you like switch the indice before or after the comma. Typically, it's not super important. But let's go ahead and change that back. Cool. So now we can use those handy dandy functions that we talked about last time, like np.mean of the data, and you can calculate the mean. So the average value over, I think this is data values since 2017. So the average value of Dogecoin is approximately 0.05 US dollars. We can find what its maximum was. $0.7. That's pretty good. If you invested when it was low, it's a lot of money. You can also find the standard deviation, just like that. And any other statistics you want to do. You can, we didn't really talk about this very much last time, but you can also calculate like a histogram of the data, like histogram values, and it'll give you like different values for each bin. You wanted to do that, and so on. So there's a lot of different things you can do with the data once you load it in. It's just a NumPy array or a giant list. So anything that you learn how to do with a list, you can do it to this data. And once you have this data, you can start plotting it. So I'm going to go ahead and give it back over to Annie to talk about the plotting.
All right, so first thing we do with every plot is importing Matplotlib. So we're going to do that as import, matplotlib dot pyplot as plt. So that's what you always do for your first step. And then after that, before you actually start creating the plot, you have to create a figure. And that's going to be plt dot figure. And I want this to be pretty big, so I'm going to set it to 12,8. So 12 is like the planks or this way, horizontal, and 8 is like the height. And then we can go into our indices. And to find the indices, it's a little confusing at first, but essentially what we're trying to do is we take the length of the data. In this case, it's around 1500, and then we find the range of the data. So to type all this out, we have range and length of data. And because the range won't be in the right data type, so we just change it to a list using that. And then now we can actually start plotting. So that's going to be plt.plot. And then our indices will be, oops, I put in dice. Okay. Indices, comma, data. Because the data like represents our Y values. And I found that the most interesting data in this case was around after 1,000 days. So I'm just going to make the X limit of this be from 1,000 to 1,500. And now let's take a look at what that looks like. Oh no, something happened. Oh, I forgot to put fig size. There we go. Okay, now it's not good. Oh, okay. There we go. Sorry about that. Okay. So now we have our data here. Oops. But we can make it look a little bit nicer by adding some titles. So we can do that with plt.title. We can just make the title Dogecoin. And then you can also change the size of the text. And to do that, that's just going to be font size. We'll make this 30 so it's nice and big. And then we can start putting in our X and Y axes labels. So for the X axes, we can write X label. And this is representing the number of days. So let's put days since November 9th, 2017. And then for our Y label, that is the price in USD. And I'll move this down to the bottom. And there you go. That's what that looks like. Yeah, I think that's it. That's all I have here. Is there a way I can zoom out and to show more of it? Oh, okay. There, that looks better. Cool. Any questions here? Yeah. Sorry, what was the first thing you said? Oh yeah. Oh, the units? I think it might be centimeters or inches or something. Do you know those?
It's confusing. Like the 12 and 8, I think technically it's supposed to be like inches, but oftentimes it's not actually making that because it's dealing with like your finite screen size, right? So it reformats it to shape it to fit properly in the screen. So it's really just about it's giving you an aspect ratio. The 12 to 8, it tells you like how wide versus how high, like how tall do I want my figure to be. And the bigger the numbers, like if you keep the same ratio the same, it'll just make everything else appear smaller. So like all the numbers get smaller and all the text gets smaller. But it's just the ratio. So if you want like really big text, make those numbers small, but keep the same ratio. I encourage you to play with it and just try different ratios. You'll see what I mean, how it works. It's kind of, there's no like there's no way to like know exactly how it'll look. So just playing with it oftentimes is the best way to do it.
Anyone else? All right.
Cool. So with the remaining time, why don't we take some time? I would like y'all to like try to make the plot yourself, recreate it if you haven't. And I encourage you to play around with some other stuff. So one thing we didn't talk about was how to use a Linspace to make like a continuous function that we can plot over this. So why don't we take 5 minutes, right? We have about 5 minutes left, and try to figure out if I wanted to make a continuous line, maybe like an exponential curve at, I don't know, 1200, try to play around with that. So maybe define a function or use NumPy's exponential function, make a linspace of numbers. Just a reminder, x is equal to np.linspace, takes in a start, we'll zoom in, takes in a start, a stop, and a number of points evenly spaced between those boundaries. And you can feed this in to a y, like y is equal to x squared. So if you have any function, maybe x exponential of x, it'll create that. And then play around with those different parameters that are in an exponential, multiply it by a number, shift it by a number, throw back to your algebra and your calculus classes, and play around with that and try to find parameters that give you like an exponential curve that kind of grows the same as this, like, and try to overplot it. And I'll throw up the relevant slides that you would need for that. Perhaps this one might be a good one, or yeah, this might be a good one, for example. So we'll take about 5 minutes to play around with this until the end. And then at the last minute, I will give announcements for the day or for the end of the day. Hi. Are you after us? No, Talc's in the room. It's probably in the room over there. Yeah, so go ahead and chat with amongst your like table and stuff on how you go about doing it and try it. And we'll come back in a few minutes. You had like 10 minutes to go, yeah, well, 5 minutes now, but maybe might be helpful to go, but I felt like I don't know, so I was here, but I feel like it's something going. I guess because like I have feeling good, but they did, and maybe like pacing. Oftentimes I find that one of the really useful tool is just repeating it, like repeating, and also asking rhetorical questions like why. So kind of like jumping that one Matplotlib, like how do you use Matplotlib? We didn't before the how do you want to, how would I go about plotting? How do I know? Like that's like yeah, what you're about. So just sorry, I'm or anything, but any advice? Oh, sorry, what'd you say? The what, the demo or the slides? They will be as soon as the lecture's over. I'm sharing this is like the slide that'll be relevant to what you want to do.
Oh, I see.
And let me make sure that the Zoom.
I have to like immediately start my job after this, so I'm just gonna set up my stuff right there.
Sounds good.
while I do all this.
Where did the Zoom call go?
Oh, it's gone?
I think I'm. Oh, there we go. There we go. Got it. Got it. For the folks on Zoom, were you able to see this? Are you still able to see the screen and everything? Okay. Cool. Cool.
Since class is like almost over, I actually have a question about importing data. So I downloaded, that one,
Right.
and it's in. So I have like on my desktop this DeCal and then set a folder for data.
Right. So if you want to access it in that, you actually need to put if this folder was outside or if this notebook is out of the data.
So just if I move this,
Well, yeah. We're,
back into here, where I'm working.
yeah. If that's it, then it should allow you to do that. But there'll still be no more errors because it doesn't know how to read this because it's if we
Yeah,
scroll
yeah.
up, it's a CSV file.
Okay.
So CSV is comma separated. So we have to set a delimiter equal to a comma, a
Okay.
string of a comma.
Okay. So that would just be comma delimiter equals comma.
Exactly. Yeah. I can. I'm gonna talk about some stuff really quick, but then I'll come back to you. Okay. All right. We have like 1 minute left, so sorry for not giving you a ton of time, but I just wanted to. Well, I just wanted to give you a couple like announcements. So the next homework will, I believe, if I remember right, it's COVID data and plotting, like basics of plotting, is in there, as well as some other fun stuff. So in order to help you, I want to show you what you have access to. So if you go to Files on B Courses, and you go to this Resources folder right here, you'll see that there's this ultimate plotting guide. Has anybody used the other guides so far? Show of hands. Anybody looked at them? That's tragic. Okay. Well, this one, I promise you, will be useful for the future homework. So open it up. It'll look like, well, I won't be able to open it up. I encourage you to just look through it, open it up. I'll talk more about it on Monday, but I promise you it'll help you with this coming up homework and the future one. So do that. Was anybody able to plot an exponential on top of the graph? It doesn't have to have agreed or anything. Just like anybody? Okay, and that's fine. We'll talk about it on Monday too. That's how we'll start. So maybe play around with that if you have some time. I'll see everybody next week on Monday. Oh, cool. Some of the Zoom folks got it. Good, good. All right, bye-bye.